Good afternoon, doctor. Today we're going to talk about a prototype design pattern by me, Shahd, Amr, Hania, and Haya. We're going to walk you through our table of contents, starting with an introduction. Then we'll walk you through the structure, and we will mention the advantages and disadvantages of it, and we will mention a couple of use cases and other design patterns, and finally, conclusion. So what is a prototype design pattern? It is a type of creational design pattern used in software development. It's used to create new objects by copying an existing object known as the prototype. A prototype involves a prototype interface that declares a cloning method. Also, concrete classes implement the prototype interface and define how objects are cloned. In simple terms, the prototype pattern allows you to create new objects by duplicating a pre-existing object. This can be more efficient than creating a new instance of the class from scratch, especially when the instantiation of a class is a costly operation in terms of both time and resources, and a similar object needs to be created multiple times. Moving on to the prototype pattern, it involves three main steps. First, define a prototype, then clone the prototype, and lastly, customize the clones. This pattern simplifies the object creation process and can help manage the complexity involved in creating objects with complicated states or configurations. The key concepts of prototype design pattern is firstly, prototype. A prototype is an existing object that serves as a blueprint for creating new object. It encapsulates the state and the behavior that can be copied to new instances. In the context of the prototype pattern, the prototype object is the one that will be cloned to produce new objects. The prototype is typically an instance of a class that implements a method for creating copies of itself. Secondly, clone. Cloning refers to the process of creating a new object that is an exact copy of an existing prototype object. This is done using a method called clone that duplicates the state of the prototype object into a new instance. The clone method ensures that all properties and attributes of the prototype are replicated in the new object, providing a shortcut for object creation.
Now let's look into the structure of the prototype design pattern. This pattern involves three main concepts: the prototype, the concrete prototype, and the client. First, we have the prototype. It's an interface that declares a method for cloning itself. Think of it like a blueprint for objects that we can make copies of themselves. We use an abstract base class to define this blueprint. Here's a simplified example. So what this code does is set up a template. Any class that wants to be a prototype has to follow this template and provide its own way of cloning. The abstract method decorator ensures that any subclass must implement the clone method, and this guarantees that all prototypes will have a clone method. Next, we have the concrete prototype. This is a class that implements the prototype and provides the actual method to create a copy of itself. Here's another simple example. So in this example, concrete prototype inherits from prototype and implements the clone method using Python's copy.dcopy function. So let's break this down. First, we initialize the object with any value. Then the clone method uses copy.dcopy to make a complete copy of the object, including all nested objects and references. This is crucial because it ensures that the cloned object is a completely independent duplicate of the original. For example, if our object contains a list or another complex data structure, deep copy ensures that these structures are also duplicated rather than just referenced. This way, changes to the cloned object do not affect the original object and vice versa. Finally, we have the client. The client is the part of our code that uses the prototype to create new objects. So the client doesn't need to know the details of how the cloning is done. It just uses the clone method. Here's also an example of how it looks like. First, the client is initialized with a prototype object, and this prototype object is expected to implement the clone method as defined in the prototype. Then the create clone method calls the clone method on the prototype to create a new object. And this method encapsulates the cloning process, making it way easier to create new objects without worrying about their specific class. Now we're going to talk about the advantages. So creating objects from scratch can be complex and time-consuming, especially if the object has many attributes or requires significant initialization. With the prototype pattern, we can create new objects by copying an existing instance, which simplifies the object creation process. Then is flexibility. Because the prototype pattern allows for a dynamic creation of new objects at runtime, this means that the exact types of objects do not need to be determined at compile time. They can be created based on existing instances. Also, increased performance by saving time and resources. Reusability. By cloning existing objects, you can reuse the setup and the state of a prototype object across multiple instances. This reduces redundancy and ensures that common configurations are easily replicated, and this is very handy in game development. And finally, the addition of new classes is simplified. When you want to add a new class that conforms to the prototype interface, you only need to ensure it implements the cloning method.
For the disadvantages of the prototype design pattern, first we have complex cloning. So making an exact copy of an object can be tricky, especially if the object is complicated or has other objects inside it. Second one is memory usage. Cloning objects can use a lot of memory, especially if you accidentally create too many copies of the object. Next, deep copies. To ensure that the copy is true and independent duplicate is actually very tricky and very hard to get. Next, inheritance problems. If a class is a part of a family of classes and the parent class does not support cloning itself, it can be very difficult to implement the prototype pattern. For the performance issues, cloning large or complex objects can slow down your program. Next, inconsistencies. If you change the original object after making clones, it can be hard to keep everything. Synchronized. Next, serialization. If cloning involves saving the object to a file and then loading the object back, this can be complicated and not all objects might support it. Last but not least, the shared state. If clones accidentally share parts with the original object, so if you change one, it might affect the others, which may lead to potential bugs.
So moving to the use cases. First one, we have the performance optimization. Imagine you're developing a high-performance video game where creating characters with detailed attributes takes a lot of time. Instead of creating each character from scratch, you can use the prototype design pattern by cloning a prototype of a pre-configured character. You significantly reduce the time and resources required for object creation. This approach helps in maintaining game performance and provides a smoother gaming experience. For the second one, we have the configuration management. In a complex graphical user interface application, there are various button configurations such as primary, secondary, and disabled buttons. Instead of manually configuring each button every time, you can create prototypes for each type of button. By cloning these prototypes, you simplify the object creation process and ensure consistency across the application. Third use case is the avoiding subclass explosion. Consider a document editor that supports different templates like letter, reports, and memos. Each template has unique formatting and settings. Instead of creating numerous subclasses to represent each type of document, you can use the prototype pattern. By cloning prototypes of each template, you manage complexity and avoid subclass explosion, making the system easier to maintain. Fourth one is the state restoration. In an application with an undo-redo functionality, it's crucial to restore objects to their previous states accurately. By using the prototype pattern, you can clone a prototype of the previous state of an object. This allows you to revert changes easily, ensure that users can undo actions seamlessly and reliably. And for a last one is the dynamic object creation. In a factory automation system, the types of machine and their configurations may vary based on production requirements. the prototype pattern allows for dynamic creation of these machines by cloning prototypes. This flexibility enables the system to adapt to changing needs efficiently without the need for extensive reconfiguration. And that's it.
While prototype design pattern allows us to copy existing objects, there are other design patterns that you may consider for more flexibility and reusability of your code. First one is the singleton design pattern, which ensures that a class has only one instance and provide a global point access to that instance. It's very useful when exactly one object is needed to coordinate actions across the systems. An example use case is the configuration settings manager and sign up classes for websites. It can also be very useful in game development. The second one is the proxy design pattern, which provides a placeholder for another object to control access to it. It acts as an intermediate layer between the client and the real objects, which in most of the cases to add additional behavior. An example use case is remote proxies for accessing objects in different address spaces, virtual proxies for delaying object creation, and the protection proxies for controlling access permissions. The final one is the memento design pattern, which allows an object's state to be saved and restored without violating its encapsulation. This is very useful for implementing the undo and redo functionality in programs. An example use case is the text editors where you can revert to previous states.
To conclude our presentation, the prototype design pattern simplifies object creation by using existing objects as prototypes. Also, it offers a flexible and efficient way to create complex objects, reducing the overhead of reinitialization. And prototype design has numerous key benefits. Some of them are, as mentioned before, performance optimization, which enhances the performance by avoiding cost of recreating objects from scratch, and simplification, which reduces the complexity of object creation and management. Lastly, flexibility, which allows for dynamic addition and removal of prototypes, facilitating easy customization. However, while prototype design pattern is beneficial, the prototype pattern requires careful handling of object states to avoid issues like shared state inconsistencies and high memory usage. Finally, the prototype design pattern is a powerful tool in the developer's collection, particularly useful in scenarios involving complex object creation and management. Understanding its implementation and potential pitfalls can significantly enhance software design and performance. Thank you.